A mere 2,174 years ago, Death Valley was the site of a catastrophic explosion. While unknown to many, Death Valley within California, which often ranks among the world's hottest locations, is surprisingly also host to a singular active volcano. This volcano consists of a chain of 14 large and deep explosion craters in the ground, the largest of which measures a whopping half a mile long, 2,450 feet wide, and 722 feet deep. To understand the sheer power of the blast that formed the largest crater of the Ubehebe Craters volcano, I will compare it side by side to that of Sedan Crater. Sedan Crater formed as the result of an underground 104 kiloton nuclear blast in 1962. And yet, Ubehebe Crater, which formed due to an explosion at a similar depth, is even larger than that massive aforementioned crater. Today, it is completely safe to visit this volcano as it currently shows no signs of life, involving 0 hot springs, 0 fumaroles, and 0 volcanic earthquakes. While this specific cluster of Mars itself is unlikely to ever erupt again, the conditions do exist for a future eruption to occur somewhere within a 6-mile radius of this spot. Such a future eruption would almost certainly also be explosive, meaning it would disrupt regional air traffic, and pose the threat of generating up to 10-kilometer-long pyroclastic flows. As a result of this threat and the potential that it could erupt again, hazard rating Ubehebe Craters is classified as an active volcano, and is listed by the U.S. Geological Survey specifically as a moderate threat volcano. If we zoom out from these craters ever so slightly fault lines and head just 3 miles to the west, there are a series of highly eroded monogenetic volcanic cones and their associated lava flows. Note how these several million-year-old features seemingly exist along 3 north to south trends, which in actuality represent now largely or completely inactive fault lines such as this feature here. And now, going back to the Ubehebe crater, there is also a fault line that extends along the crater's longest orientation, hence the color difference in rock units seen in this image. Both of these features, despite forming millions of years apart, formed due to the same geologic setting which could one day power a similar future eruption. These faults formed due to the intersection of 2 tectonic provinces, the geologic setting basin and range, and the Walker Lane. The Walker Lane is a series of faults that accommodates the vast majority of the region's tectonic plate motion not accommodated by the San Andreas Fault. Meanwhile, the basin and range represents a broad area where the crust is slowly spreading apart, forming many fault lines. The created fault lines from this motion serve as weak spots in the crust.